Glass is usually hard, brittle, and transparent. Brittle, we said, is hard, but it breaks what? Easily. unlike cement, they are non-crystalline solids. Yes?
Yes.
Do you know a crystal? Yes? If they say something is crystalline, do you know how it looks like? Yes?
Yes.
How does it look like?
No.
Brian, you don't know a crystal? Huh?
I know.
You know?
Yes.
Okay, let me show you how it looks like. Crystal. Do you see crystals?
Yes.
You have seen them. Now, is the sugar a crystal or something else?
No.
Is sugar a crystal or a powder? Huh? You have told me you have looked at the structure of a crystal. That's how they look like. Have you seen them? Huh?
Yes.
You look at this one.
Yes.
You look at this one. Have you seen this?
Yes.
This one. You have seen it. Yeah? Brian.
Yes.
Now,
Yes.
doesn't this look like a sugar crystal? Huh? So if this is the way it looks like, then it means that sugar is also what? A crystal. You get it?
Yes.
So there's a difference between a crystal and a powder. Let me show you how a powder looks like. You know powder? Yes?
Yes.
Powder is more reformed than a
No.
crystal. Okay? So if you look at this is the way our powder looks like. You see this? Yes? Brian?
Yes.
Okay. Anena?
Yes.
Anena?
Yes.
Anena? Anena? Yes? Anena? So you must put to differentiate between a powder and a crystal. And at the moment, that's what they are trying to mean here. That glass are usually hard, brittle, and transparent. Unlike cement, they are non-crystalline glass. When you look at glass, do they look like crystals? Yes? Who is hitting what? Who is hitting what? Okay. Them are arranged in any pattern. So those molecules in glass, they are arranged in different patterns. Okay? So you will remember that a liquid structure has molecules closely packed, but not arranged in any pattern. It's not like solids, where particles are arranged in all patterns. The reason that's why solids have a shape is because their particles are arranged in certain pattern. In the liquids, they don't have what? They are actually they follow the shape of the container. Okay? While those ones of gases randomly move. So here they are saying this means that glass has a structure like a liquid, but the molecules are too large to move around. They are intact. They are too large to move what? Around. While those ones in water, they can move around, they can slide over each other. That's why if you touch water, it is somehow slippery. Okay? If you touch water, it's somehow slippery because it has the ability of sliding over its own molecules. So that is what happens here. But for glass, the molecules are too large to move around, so they stay together intact and they form a solid bit of it. So glass are really liquids that behave like solids. Glasses are real liquids that behave like solids. Because if you look at their structure, the structure of glass, it has a structure, it behaves like a liquid, but the molecules are too large to move. Now let me show you the image here of glass. I want to show you the hard one. Let's look at this. We look at this. Now here is a different type of glasses we use for taking water. When you look at those glasses, there are some that have curves somewhere. So instead they look like water, but their particles are not, they cannot move. They are too big to move. But in the water, they can move. Okay? You look at this. So this, they look like water. That's what they are trying to mean there. So here, they are saying the common kind of glasses are made by heating limestone. Limestone is calcium carbonate with sodium carbonate. All these chemicals, you will know them when you come to writing chemical equations or chemical compounds. These are an element mixed with another substance called radical. So this is calcium carbonate mixed with sodium carbonate and sand. That sand has what we call silicon dioxide. All these are burnt in a furnace. Somebody was asking for how a furnace looks like. If you look at this, a furnace is like this. There are many types of furnace. Those people who know iron smelting, this is what happens inside the furnace. Inside the furnace, it looks like this. This is the way furnace looks like. Inside it is like this. This one is the furnace. But what happens in the furnace? What happens in the furnace is this. This kind of heating. This one. So this is the heat from the furnace. And you see how red it is. If they dump you there, even if you're metal, you will change to a liquid. Okay? This fire has been kept there for some good time. It's not the one you make for one day. So this is made by continuous burning. And the kind of things they use for burning here is coal, not wood. Otherwise, people would have used all the wood and finished. Anena, are you understanding? Anena? Anena? Unmute.
Yes, teacher.
You have not seen how a furnace looks like. You have seen how a furnace looks like. Yes? Eh? Have you seen a furnace? Yes? Anena? Anena, are you there? Brian? Yes, Brian. Yes? Brian?
Yes.
Brian, have you seen how a furnace looks like?
Yes.
So if they throw you in that fire, you know where to fall. Yes.
Yes.
So that is how it looks like. So that is the structure of a furnace here. If you look at it, this is the way they build it. This diagram here. Okay? This is the way it looks. But what comes out of the furnace is this fire you see. This one. You see how already hot it is.
Yes.
Okay? At this stage, this temperature is beyond 100. It is in thousands. Okay? If by mistake you just pass by all the leg groups there, you will see. So Anena has also seen. Anena,
Yes, teacher.
you have seen what we mean by furnace.
Furnace, this one that it's like the rich in China 5-ton medium frequency.
This one. This is the way it is built. Okay? Now outside they put metal. Okay? Then inside in the same wall they put what? They put clay. Okay? We shall know why they use clay inside. But first we are looking at the glass. We have looked at the glass and what? Concrete. You get? So now we are looking at glass, but we have seen that to make a glass, it is burnt in a furnace. So I wanted to show you how a furnace looks like. Is it clear? So this is one. But what comes out of this furnace? The fire that is used here is as red as this. You see that? You have seen?
Yes.
Then have you seen? Okay? This fire is in thousands. It is not even in 100 degrees Celsius. It is 1,000 degrees Celsius. Okay? So that is the one they use for heating metals. Okay. Let's go back to our discussion. They say the kind of glass, the common kind of glass is made by heating limestone, calcium carbonate with sodium carbonate and sand, which is silicon dioxide, in a furnace. If you heat limestone with sodium carbonate and sand, you will form glass. At the end of the day, if you burn it in the furnace, that's how it looks like. The three components melt together and run out of the bottom of the furnace as clear liquid. Okay? You get it? Brian?
Yes.
You have seen what the glass is made up of?
Yes.
They use limestone. They use a carbonate, okay? Sodium carbonate and what? Sand. Have you seen?
Yes.
Okay. Where is the Anena? Anena?
Yes, teacher.
Glass is made up of
Limestone. The
With
limestone and the carbonate.
sodium carbonate, okay? Carbonate, you get? Okay? And the sand. If they are
Sodium, yeah.
so the three compounds melt together and run out of the furnace as a clear what?
Clear liquid.
Now,
Clear
yes.
liquid.
Now, how do you turn this liquid to any shape that is called a glass? Yes? So this is what they are trying to show down here, that the liquid can be allowed to cool has a flat sheet. Those flat sheets are the ones they lay on the windows. You get? Is it clear? Yes?
Yes.
So
Yes.
the liquid can be allowed to cool as a flat sheet of glass and can be molded into different shapes before it cools and turns into a solid. You can't turn this one of ours back to a container we are going to use for carrying water. You better pour it and it cools in the shape you want it to be. Okay? So other substances, pure, particularly metal oxides, can be added to change. Then you can also use some color. Okay? You can also use some color to change the appearance. So they say this can be added to make different kinds of glass. Some of these glasses are colored, particularly because of this metal oxide. Do you get? Yes?
Yes.
Okay. Let me hope I'm sound and clear. You must be position to tell us that glass and concrete, there are two different types of what? Materials. Is it clear?
Yes.
Okay. Now, this is an example of showing a shattered glass. The glass has turned into what? What do you mean by shattered? A shatter? Okay. Maybe you have the notes. You have the notes with you. Where you have the notes. And then I say she has not understood what the thing makes glass. If you mix limestone, sodium carbonate, and sand and heat them together in a furnace, the liquid that comes out, the three components after they have melted together, melting is a change of state from solid to liquid. Now, if these three components are melted together and run out of the bottom of the furnace, they run out of the bottom of the furnace as a clear liquid. Now, this liquid can be allowed to cool as a flat sheet. An example are the glass windows. Those are the ones that have cooled like that. Or it can be molded into any shape. You can form any shape. Then you make the liquid glass to follow that shape. It comes out as a round glass. That is another way you can make it. So if you want to change the color of that clear liquid, you add metal oxides. Metal oxide. If you want, the main metal they use here is like zinc oxide or lead oxide. Those are some of the oxides they use. Okay? So if you add zinc oxide to this, the color of this colorless liquid here, this colorless liquid that we poured out, changes from colorless to either red or green or something of the kind. And then am I clear now? Yes? Anena,
Yes.
you have understood now? Yes?
Yes.
Okay. So
Yes.
if they ask you how those things are made, you must be positioned to give a brief description. That in the glass we have limestone, sodium carbonate, and sand. If you heat those three in a furnace, a liquid will come out. That liquid is colorless. Okay? Now, as it dries, it forms, maybe you allow it to dry on a certain platform that is flat. It will form you, it will give you a flat, what? A flat glass. If you can mold in a shape like a mortar and a pestle, and then you pour, it will give you a glass-like structure, the one used for holding water. Finished. If you want to change the color of that colorless liquid, you use any metal oxide. Metal like lead oxide, you pour inside, then the color automatically will change to what you want. Is it clear? So, another, we looked at the shatter. shatter is a solid turning into pieces as fast as it can. This is an example of a glass that has been hit maybe by a stone. Where the stone hits, it has cracked and turned into pieces as easy as possible. You get? Although glass you have tested broke easily, certain types of glass, like the bulletproof glass, do not break easily. These president cars have this kind of bulletproof glass. Whether they are short or not, they just remain the same way. Okay? So inside the bulletproof glass, there are very many materials we put. Okay? Just like the way you get this clay, you add it to iron, then you use it in a furnace for heating. Okay? The reason that's why they use clay doesn't melt easily. Is it clear? Yes?
Yes.
Okay. Now, those are two examples. The other one is ceramics. Ceramics, we are dealing with pottery. Okay? Which material do you use for making pots? Yes? Anana. Which material do you use
Yes.
for making pots?
Clay soil.
Not loam soil. What is the use of loam soil? Huh?
What?
Loam soil. What do they use? What is the use of loam soil?
Loam soils are used for building. For building.
Loam soil. I thought clay is the one for building. Yeah?
Loam soil.
Yeah.
Sand.
Now, can't I use
Sand is used for building.
can't I use concrete for making pots? Huh?
You can.
You can. But what is the problem? Is there any problem if I use concrete for making pots? Yes? Brian.
Yes.
If I use
Yes.
concrete for making pots, whatever is there? What is the problem with it? Huh? Yes? You don't know? Huh?
Yes.
Okay. That is the reason that's why you must study this thing called ceramics, because it is the one that is involved in the pottery. You get? You get it? Clay is something natural. You can get it from anywhere. Concrete is as a result of a mixture of sand, cement, and what? And gravel. Now, just assume your pot is made up of that material, and then the pot is made up of clay. Which one is more safer to use? Yes? Huh? Which one is more safer to use? So if they are saying the piece of pottery, you get a piece of pottery, then you try to mold into different shapes, like this one. Have you seen pots here? Those nice looking pots. So here they are saying ceramic objects are made from clay. You can't use your cement for making. You can use cement, but cement is more dangerous to human life than clay. Okay? So they are saying ceramic objects are made from clay, which is common in all over the world. Okay? You find the antehills everywhere in the world. Everywhere you find clay. In the swamp you find clay. So clay contains a mixture of mainly aluminium oxide and silicon dioxide. We saw that from our definition of glass, silicon dioxide is written as sand. Okay? So here they are saying it's a mixture of aluminum oxide and silicon dioxide. In simple terms, this silicon dioxide is what? Sand. So it has several important properties which have caused it to be used for making pottery objects. Number one, it can easily be molded when wet. It can easily be molded when what? Wet. Anena, are you there? Anena,
Yes.
are you there?
Yes, teacher.
Now a question is here. Clay can easily be molded when wet. Can you mold cement when it's wet? Yes. You're coming after. Okay. Anena. Anena. Anena.
Yes, teacher.
Can
Yes,
you
teacher.
mold cement when it is wet? Yeah? You see, that is the difficulty of molding cement or glass when it's wet. It is not easy to mold. But clay, you have that ability of molding it when it's still wet. This is because the molecules in clay attract water molecules by electrostatic attraction. Yes. Electrostatic attraction is if you get your pen and rub it, then you bring it to a paper, you sit pulling some papers around. You get? Is it? You did those experiments in primary. Okay? Brian,
Yes.
are you following?
Yes.
Okay. So these water molecules allow the clay molecules to slip each other around. So if you just slide the clay over each other, it will go because molecules of water are also there. And then, but if you get cement or concrete, for you to get that concrete and put it together, you need a certain container, which is very hard to make. So here, then also they are saying when clay dries, it goes hard. Okay? Then if clay is heated in a fire or an oven, it goes permanently hard. But if you heat cement, I don't know how hard it can be. Okay? When clay is fired, the molecules in clay react with each other and a hard giant structure is produced. Okay? Let me show you a structure of a giant whatever. Structure of a giant molecule. A giant molecule. This is what we are meaning. So these things you see here are all giant molecules. These things that look like dots, the round ones, is one element. Now, if there are many of them together, have you seen how they build each other to form a giant molecule? Yes? So these black dots, you see these ones, they are the examples we are saying. An element, an element, an element, an element. So if you combine all of them, they are very many. They form what we call a giant molecule. That is the same as clay. That's what clay does. It has the ability to form a giant what? Molecule. The structure is similar to the structure of silicon dioxide, which is sand. Okay? So if you look at the structure of sand, so these are the example of homemade pot clays. This is from Arua. Who is from Arua? Huh? Anana. Are you from Arua? Yes? Because they are telling us that these pots were brought from, they are made from Arua. Yes? Anena,
Yes, teacher.
I don't want to leave you behind. Let's be talking, okay?
Yes.
So are you from Arua? These pots were brought from Arua? Yeah?
No, I'm not
Okay.
from Arua.
Very good. So these pots,
I'm not from Arua.
it is okay. So these are the pots. These are homemade clay pots from Arua. These are handmade pots. They are handmade. But you see the shape they have. Because clay has the ability to form the giant what? A hard giant structure. I will show you how the giant structure is. If you want to look at it again, it is here. The giant structure. This is the giant structure of diamond, giant structure of graphite. Okay? So that is what we have there. Now, any question before you go further? Yes? Brian,
Yes.
any question? There is no question. Anana,
Yes.
any question so far? There is none. Yes? Yes? Anana, there is
Yes,
no
teacher.
question. There is no question.
Yes.
Why? The question is, why do they like ceramics for making pots other than glass? Why? Yes? Why do you like ceramics for making pots other than glass? And then I'm waiting. Brian, why do they like ceramic material for making pots other than glass?
Because
Hey,
clay can be molded easily.
thank you very much. And then the next reason? Huh? And then
Yes.
why do they like those materials? Huh? Next reason? Huh? Yes.
The clam.
Clay does what? Why don't they like making
The clay molecules.
the
The
clay
clay molecules to slip easily around the.
the
It
what?
is easy for the. It is easy for clay molecules to slip easily around each other.
Other than what? Other than the glass material, isn't it? So
Yeah.
if you study the structures or the properties of clay here, you will come to see that clay is fired. Clay is fired when you fire clay. Okay, when you put clay to when you burn clay, the molecules attract each other or they come closer to each other and form a giant what? Structure. Now, if you put fire on glass, what will happen to glass? It will do what? And then what happens to glass when you heat it?
When heated,
Yes.
the glass will break into smaller particles.
Okay, thank you very much. Those are some of the reasons you should be reasoning with. Okay?
Yeah.
So when they ask you what they like these materials for making pots other than maybe other things. The most important to tell people what happens, okay?
Yes.
So next time we meet, we shall start with the plastics. Okay?
Yes.
We have 3 minutes to finish, but maybe 1 minute I will give you, and then for whatever you have not understood, you ask. It's okay. Huh?
Yes.
Yes, I'm waiting for a good question from Anena. Just like the one I've asked you. Actually, you can even say why don't they use the concrete for making what pots? Why? Okay, what is the common line of those? Anena,
Yes, teacher.
why don't they use the other material like concrete for making pots?
A concrete.
Yes? I'm waiting. Brian,
Yes.
help Anena. Anena has failed. Why don't they use concrete for making pots? Yes? Now the thing is like this,
Because concrete cannot be molded easily.
Cannot be molded easily.
Yes.
Okay? Those are some of the reasons. Anena, if you look at the
Yes.
materials they use for making concrete, we have cement, sand, and what? Cement, sand, and yes?
Clay.
Cement,
Cement.
Cement, sand, and stones, isn't it? Gravel, is it?
Yes.
Okay. Now, just imagine you are molding your pot with those things. Can the shape come out like this one? Yes? Can the shape come out like this?
No.
Actually, it will even have some holes inside. It will pour water out. You get it? Is it clear? Yes?
Yes.
Okay. Now, this question of yours, you make sure you attend tomorrow. We shall answer it tomorrow. Is it clear?
Yes.
Anena? Anena? Anena, you have gone.
Yes.
This question of yours, you ask it
No.
tomorrow. Okay? Yes?
Okay.
Yeah.
Okay, teacher.
I will start with that one tomorrow.